Question 1 was name a five-sided polygon. So I put all the polygons on here for you just so we can take a look at all of them one more time real quick. A three-sided polygon, we've got triangle, 4 would be quadrilateral. The one we want is the pentagon, which has 5 sides. 6 would be hexagon, 7 would be heptagon, 8 would be octagon, 9 would be nonagon, and 10 would be decagon. A real nice way to help remember these is just remember the prefixes, because most of the words have agon after it, so you don't have to worry about that part. Everything except for basically triangle and quadrilateral, and I'm sure that you guys know those anyway. So the prefixes really help, I think. But the five-sided polygon is a pentagon. Alright, so now we've got the difference between a regular polygon and an irregular polygon. First up here I started with what would be included with both of these. Any polygon, no matter if it's regular or irregular, is two-dimensional, meaning it's flat, it's closed up, there's no openings in it, and it doesn't have any curves to it. That's for every polygon. Now, to separate the two, it just depends on the side lengths. If everything is nice and uniform and equal, it's going to be a regular polygon. If everything is irregular, meaning the different sides, it just doesn't look nice and uniform, then it's going to be an irregular polygon. So an example that I gave is a regular quadrilateral and an irregular quadrilateral. Regular quadrilateral is, in this case, it's a square. All the sides are the same. Irregular quadrilateral is whatever this is. It's just a quadrilateral. There's nothing, no special name for it here. But all the sides, or some of the sides, are different lengths. Okay? They're just not all the same like this one. So you could have had any shape for an example. You could do a regular and irregular decagon. Okay? An irregular decagon would just have all the sides being exactly uniform and the same. Irregular decagon, they would not all be uniform and the same. These were just the road signs that I could think of off the top of my head. There actually, there might be a road sign for every single type of polygon, up to 10. I don't know. I don't know about nonagon or decagon, but it's possible. So and there's a lot more than this. If you came up with a different one that matches a polygon, you're in good shape. I know that a yield sign's kind of an upside down triangle, so that's definitely a polygon. A stop sign has 8 sides, so a stop sign's an octagon. And I know school crossing signs, they don't look like this, but that's what kind of sign it is. And they are kind of almost house-shaped, which would be a pentagon because it's got 5 sides. So if you've got something different than this, it's perfectly fine, as long as it's a real sign and it matches up with one of our polygons. Now, I believe that most of you know what a square looks like. That's not the question here. But the question is, all the properties that are given to a square, all the properties that a square has, make it a lot of different things. I'm just going to go down the list here. I've wrote down the 5 properties that a square has that I've got anyway, and then we can call it some different things. This is definitely a square, okay? But it doesn't have to just be a square. It's got 4 sides, so we can call it a quadrilateral for sure, okay? The opposite sides are congruent, meaning the opposite sides are equal in length. If the opposite sides are equal in length, we can call it a rectangle. We can call this a rectangle. Okay? It's got 2 pairs of parallel sides. Parallel, parallel, and then parallel and parallel. Okay? That makes it a parallelogram. Can be that. All 90-degree angles. Okay? This again will make it a rectangle slash square. And then all congruent sides, this can make it a rhombus. So square is kind of a unique thing because it can be every type of quadrilateral except for a trapezoid. Trapezoid it can't be because a trapezoid only has 1 pair of parallel sides. This has 2. But otherwise we could call a square a rectangle, quadrilateral, a parallelogram, a rhombus, and a square. Any of those things will work. This irregular nonagon was actually probably a lot easier for me to draw than a regular one. I'm not even sure if I could draw a regular one. That would be pretty tough. I would really have to think about that one. But a regular's easy. You can just make lines until you get up to 9 and then close it off. So yours is probably going to look different than mine. But you just have to make sure that it's all closed up, which mine is. Mine's obviously two-dimensional, and there's no curves to it. Then you just have to count up the sides. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So this is an irregular nonagon. Trapezoid is actually probably one of the more specific quadrilateral shapes, whereas it's got to be a certain thing or it's not going to be a trapezoid. So the couple things. Here are the trapezoids you're probably going to see. This is a right trapezoid because it's got a right angle in it. This one is just your standard trapezoid. Oh, to be a trapezoid, we have to have 4 total sides. Okay, that's obvious. And both of these have 4 sides. Oops, don't want to draw that because that means they're all equal. Let me just know. Well, you guys can count yourselves. 1, 2, 3, 4. 1, 2, 3, 4. Definitely has 4 sides. Now, the main thing for a trapezoid is only one pair. Keyword only one pair of parallel sides. So if you look at this one, this side would be parallel to this side. They're never going to touch if they just keep going. Now, these two here and cross right there. So that is not parallel, which is good for a trapezoid because it can only have one pair of parallel sides, not 2. If it's got 2, it's a parallelogram. This one, parallel and parallel, so we got that. Now the other two, there and there. Those two are going to eventually cross, so that is definitely a trapezoid because there's only one pair of parallel sides. So for a trapezoid, it needs to have 4 total sides because it's a quadrilateral, and it can only have one pair of parallel sides. Alright, so now what we're going to do is we're going to analyze this statement. Every square is a rectangle, but every rectangle is not a square. Okay, it sounds pretty confusing. But I think if we lay it out with this picture, we can tell. Okay, let's just focus on the first one. Square is a rectangle. Okay, now first of all, they both have to have 4 right angles. Okay, so those are the same about them. Now we got to see if a square can fit into everything that a rectangle has to be. We know a square has 4 right angles. Does a square have opposite sides equal? Those are equal. Those are equal. So yes, it does have opposite sides equal. So no matter what your square looks like, it's going to be a rectangle because it falls into both of these categories. Okay, so that's a check. That's definitely good. Now, the other way around, a rectangle is not a square. Okay, a rectangle does have the 4 right angles, but does it match the other criteria? The other criteria to be a square is it has to have 4 equal sides. If I look at this, I do not have 4 equal sides. Okay, so this is not a square. So I'm going to just write this up here. Not square. Can't be, because it doesn't meet all the square's criteria, all the square's properties. So down here, a square is not a rectangle. Yeah, that's also true. A square isn't a rectangle. So this whole statement is going to be true. If you ever get a question like this for different shapes, I recommend that you write down, draw both shapes, put the properties underneath them, and then just do the side-to-side test here. We can easily see that a square fits both of a rectangle's categories. So it is a rectangle. But a rectangle does not fit all the square's categories, so it's not a square.